Welcome guys to the best math channel in the world, say on Busy Made It Easy channel. The only channel in Ghana is Fears. The only channel we make mathematics easy for beginners who are beginning to like mathematics. Today we are going to move on to our previous lesson or the previous series, which is indices and the logarithm. And today on logarithm we are going to talk about the change of base method as promised, which is one examinable area and one tricky area that you need to understand and master, and this channel is going to make it very easy for you. So the change of base method, let's say we have log base AB. Yes, log base AB, assuming the answer we are going to get, if the answer is C, yes, we end up having something like log to the base C power B all over log to the base A log to the base C power A. Yes, this means we have changed the base and we are going to get the same thing. Yes, we have changed the base and we are going to make we are going to get the same answer. Now, another principle is if you want to know the change of base in any question, I'm going to teach you two methods to apply the change of base method. So this one, I'm expressing it like this, or this, if you see log to the base AB, it can also be expressed as log B all over log A, for which you're also going to get the same answer. And this one, they will have a common base. And you know, a log without a base is in power 10. Yes, that's what we are going to. And the first principle is this same log base AB. Here you are going to find the common factor for the B. And the common factor of A. The first method, you find the common factor for A and the B. Yes, then you rewrite the common factor as power of the base. Yes. So I'm going to solve first question and you are going to understand it. So you are going to find the common factor for A and the B. Then you are going to rewrite the factor or the number as power of the base that you have gotten. Then when you finish, you replace them, then you use the logarithm principle to solve. Yes, so this is the idea about the change of base. So you end up solving with changing the what? The bases and getting the same answer when you have to use the normal logarithm principle, you know. So without wasting my time, we are going to solve our first question to see how the change of base method is applied. Log base 9 is equal to log base 927. We have to use the change of base method to solve this. And in my introduction, so this one is going to give us log to the base 27 over log to the base 9. For my introduction, log to the base 27 by log to the base 9. And I've told you earlier, now we are going to find the common factor. So the common factor for 9 and 27 is 3. So I'm going to express this log as power of the common factor. So this one will give me log base 3 27, then log base 3 9. Yes, what has happened? The base has changed. Yes, the base has changed here. So I'm going to express this. Now, log base 3. Now, 27 is going to be 3 raised to the power 3 all over the log base 9 also give me log base 3 raised to the power 2. Yes, 3 raised to the power 2. And you know, in a given log, when we get a log like this, now I'm going to continue from here, so follow closely. Now this one will give me 3 log 3 all over, then this one is going to give me 2 log 3. Yes, 3 log 3, then 2 log 3. Yes, so this is what I'm going to get. Yes, with their bases. 3. Yes, with their bases. Yes, with their bases. So now this one will give me 3 times 1. Log of itself is 1. Then this one will give me 2 times the same 1. The log of itself is 1. So this one will give me 3 on 2. So therefore, using the change of base method, the answer here is going to be 3 on 2. Yes, this is how we solve it. So you find the common factor for the number and the base. Then you rewrite them as the power of the base. Then use the normal logarithm principle to solve. Now, method 2. Let's look at how method 2 is also solved using this same question. So, the same log base 9, 27. Yes, log base 9, 27. This one is very simple. So, you can express them log 27 all over log 9. Yes, you can just write them as this, log 27 all over log 9. So now I've changed the base. Is it true? Yes, because here I was having base 9. So expressing them like this, they will have log base 10. Yes, a log without a base is in base 10. So here, with the help of our calculator, when you punch log 27 divided by log 9, you are still going to get 3 on 2, for which you can try with your calculator. So this is what the change of base method is about. So you writing them like this, you writing them like this will let you have the same answer. So we are quickly going to take our next question on the change of base method. So as the second question is posted on the screen, log base 2, 8. We are still using the change of base method to solve this. Yes, to solve this. So common factor for 2 and 8 is going to be 2. Yes, so we are going to express it. Now have log base 2, 8 over log base 2, 2. Now I'm going to express the number in power of the base. So this is going to give me log to the base 2, 2 raised to the power 3 will give me 8. Then still log the base 2, 2. This one power 1 is the same thing. So in a normal logarithm principle, so the power will come here, log base 2, 2, 3 log base 2, 2. Then I'm going to have this one 1. So I'll still have log base 2, 2. So I'm going to continue here. So this one will give me 3 times 1. Log to the base of itself is 1. Then all over log to the base itself is also 1. So this one is going to be 3 divided on 1, which is the same as what? 3. Yeah, this is how this is solved. So you can try that. That's when anytime you punch log 2, log base 2, 8, you get 3. So with the change of base method, this is how we solve. Why are we saying change of base? Change of base. So we change the base, yes, to get a common log so that we can solve. So in the method 2, the same principle. Yes, method 2, if you have log 2 base 8, is going to give us log 8 all over log 2. You change the base, now they will have a common base, which is 10. That we don't write. So in your calculator, when you divide log 8 by log 2, you are also still going to get 3 as the answer. Yes, you are going to get 3 as the answer. So the change of base, this is how we solve it. Yes, so in a given question, you should know how you are going to express them, then you solve them. Yeah, we use the change of base because sometimes some calculators might not have the logarithm function and those things on them. Yes, so or maybe without your calculator, you'll be able to express them as a simple logarithm that you solve. So this is how we use the change of base to solve a given logarithm. So we are going to take the third question on this. So as the question is posted on the screen, log base 525. Now we are going to use the change of base method to solve this one too. So the common factor for 5 and 25 is definitely going to be 5. So this can be written as log 25 all over log 5. Log 25 all over log 5. So I've changed the base here because I've changed the base from 5 to 10 that normally log we don't write. So that's why I keep saying, that's why I say the change of base. So let's express, yes, let's express the 25 as power of the old base. So this one will give me log 5 raised to the power 2 over log 5. Yes, over log 5. Then this one will give me log to the base 5 all over log 5 as well here. So now let me continue here. So this one will give me log to the base 1 all over 1 again. So this one is 2 on 1, for which is the same as 2. So you can try that with a calculator. It's going to give you the 2. So I've used a change of base method to solve this by expressing this as power of the old base. This one I'm not going to use the method 2. But the method 2 simply see something like this, and by the help of calculator you are going to get the correct answer. So we are quickly going to take another question on the change of base method. As the third question is posted on the screen, now we have log to the base 381 that we are going to use the change of base method to solve. So this one is going to give me log base 381. The common factor for 81 and 3 is going to be 3. So all over log to the base 3. Now I'm going to express the 81 as power of the 3. Yes, for which will give me log base 3 raised to the power 3. Sorry, 3 raised to the power 4. 3 times 3 times 3 times 3. 3 3 9 90 27. 27 times 3 is 81. So it's 4. So now here, say log base 3. So in logarithms, so this will give me 4 log base 3 all over log base 3. So this one will give me 4 times log to the base of itself is 1. Then the log of itself is 1. So 4 on 1, which will also give me 4. Using the change of base method to follow closely. Yes, change of base method is so simple if you understand the principle and how to solve it. So this is how we solve this one, to using the change of base method. So we are going to take another question on the change of base method. Posted on the screen, we have log base 892. We have to use the change of base method to solve it. So the common factor for 8 and 92 is going to give us, the common factor is still going to be 2. So this one is going to be log 292 all over log 28. Yes. Can I express this 92 as power of 2? No, so I'll leave it. So I have log 292. But the down one I can express that power of 2. So that one will give me log base 2 raised to the power 3. So this one will give me still log 2 base 292. Then this one 3 log 2. So I'm going to have log to the base 292 all over 3 times 1, log to the base of itself. So this one is going to give me log 292 all over 3. Yes, I maintain the 92 because I can't express the 92 in power of 4 2s. But the down one, I can express it as power of 2s. So if you encounter a challenge like this, this is how it is solved. And if you have to leave your answer in decimal, you can just punch this by the help of the calculator, whether in significant figures or decimal places, then you leave your answer as such. Since they said if you just use a change of base method, that's why I ended on this hour. I ended an answer like this. So we are going to take our last question on the change of base method. So as the last question is posted, log base 30 100. So we have to use the change of base method to solve this. And as we know, what will be the common factor for the base 30 and 100 is going to be 10. Yes, it's going to be 10. So this one is going to be log 10 100 over log base 10 30. Yes, log base 10 100 and log base 10 30. Can I express the 10 as power of the 10? Yes. But the 30, no. So I'm going to leave it. So this one will give me log base 10 raised to the power 2, which will give me 100 all over log base 10 30. So 2 log base 10 all over log 10 30. Yes, so this top one is going to give me 2 times 1, log to the base itself is 1, then log base 10 30. So this will give me 2 on log base 10 30 as my final answer. So this is how we use the change of base method to solve any given log question. Yes, so students demanded I make a lesson on it. That's why I've taken my time to explain. So this is the end of today's part on the change of base method on logarithm. So we are going to learn the last part of logarithm, which is going to be exponential equation 2. Yes, which is finding the true set in a given logarithm, which is further mathematics. It's a topic in further mathematics. So until we meet again, this is Seyon Busy Made It Easy channel, the only channel exam fears and the best math channel in the world. Don't forget to subscribe and recommend to all students at the lower and the higher level to also have a benefit again on this lesson. Until we meet again, we say goodbye for now and watch out for more.